Hi everybody. Today we are going to do the lab, can you make an egg float? Okay. Materials needed are water, 2 raw eggs. It does not matter whether they are chicken or duck. What does matter is for our experiment to be the most accurate that it can be, we would like those 2 eggs to preferably be the same color and almost the same size. Okay. Liquid soap, cooking oil, salt, sugar, glass. By glass, it means 2 glasses that can fit an egg. You don't have to actually have beakers like I have, but I am using the beakers because they are more helpful, and you can also see how much they go up in the video. And a tablespoon and a spoon and a pencil. Okay, so fill a glass half full with room temperature water. Place 1 egg into the water. What happens and why? Okay, my water is not yet room temperature, so I'm gonna add a little bit of hot water. All right, I have fixed my water, now it is room temperature. Okay, fill a glass half full with room temperature water. Place 1 raw egg into the water. What happens and why? Before I do that, I want to add a little bit more science into this project. Sorry, I had to check the back of my table to make sure I don't knock anything onto the cat. All right, so I have a scale here, and I am turning it to grams. And I'm also zeroing it out, which means anything on it is then 0. So I'm going to put this glass, the beaker, on there. And right now, the beaker weighs 111 grams. I want to zero it out, so that way it's back to 0, including the glass. So that way I can weigh the egg itself. So I'm gently putting my egg in there to find out how much my egg weighs. All right, this egg weighs 59 grams, so I'm going to label this one egg 1, 59 grams. Grams is notated with a G. Okay. I am also going to label my egg 1 with a 1. You don't have to do that. 2. Okay. Make sure it's back to 0. Put my egg in. I tried to make it pretty much the same size, and we're going to see how well I did. 55 grams, so I'm pretty darn close. All right, egg 1 was 59 grams, egg 2 is 55 grams. That's pretty close. Okay. Now I don't need this anymore. So I'm just gonna put this off to the side. Okay. All right. There we go. Okay, it says fill a glass half full with room temperature water. Half full, half of 250 is 150. Okay. Now, if I'm using a beaker and I want to make sure that it is actually at 150, you go level with the line. And when my eyes are level with the line that I'm looking at and the water level is level with the line, then I in fact have it at 150 milliliters. Okay, this beaker is slightly smaller. It's only a 200 milliliter beaker, but we are going to fill it half full, which is 100. Okay. If I had 250 milliliter, 2 beakers of that, I would, but unfortunately I only have the 200 and the 250. So we are going to use them and know that both of them are half. Okay, that one's at 100. Just double checking my work. Okay. Place 1 raw egg into the water. Now first, we need to take a guess. Predict what? What do you think is going to happen? Is the egg going to sink? Is it going to float? Is it going to borderline float, but it's still touching the bottom? What is it going to do? All right. Now that you have your prediction of what you think it's going to do, we are going to stick egg 1 in. I think it's going to sink. It did sink, however, it is upright. Okay. I'm gonna take them out of the tray so you can see better. I wanted the tray so I don't make a mess on the table, but that's okay. Okay. We are in reverse order on the camera, so I'm gonna do that. Okay. It says what happens and why. So what happens? It is top facing down, but pretty much it is sunk. The egg sunk to the bottom, but top of egg is touching the bottom. Okay, now we should just make sure that egg number 2 also sinks. And was it possibly the way that I put it in? So I'm gonna put this one in sideways. Nope, it still went top down, still sunk. Okay, that's good to know. All right, next up, the egg will sink because the egg is more blank than the water. So your job is to answer that blank. What word do you think that is? Our science vocabulary for this experiment is mixture, molecules, buoyancy, mass, and density. So which one of those words matches the egg will sink because the egg is more blank, put one of those words there, than the water? All right. Add salt to the water 1 tablespoon at a time. Stir the water and the salt to help the salt dissolve quickly. What happens to the egg and the water as you add salt? Okay. That's what our tablespoon is for. I have to remember that this one here is the one you guys see as number 1. Okay. I'm going to use the tray on the side. This. Okay, 1 tablespoon means a flat tablespoon. So I'm just going to pat down my mound to make sure that it's at 1 tablespoon. Okay. And I'm pouring it in evenly. All right. Stir the water and salt to help the salt dissolve quickly. I assume that's what our spoon is for. Okay, so there will become a point at which all of the water has been saturated with salt molecules that there is no more availability to add any more salts and it dissolve. So the salt will just be displaced at the bottom because it cannot dissolve anymore. Okay, when we talk about dissolving, is that a physical or a chemical change? Okay, I hope you said it's a physical change because the molecules in this cup right now are H2O, 2 hydrogens, 1 oxygen, which is water, and NaCl, which is sodium chloride, which is table salt. They are 2 separate molecules floating around with each other in this container or beaker. If I was to go and boil this water, I could get the salt right back out. And it should be the exact same amount of salt that I get out. And if I was to use some sort of device to catch the water vapor, I should be able to get all of that water out too and have them completely separated. So this is dissolving is a mixture, and it is a physical change. Okay, it looks like my water has been saturated with salt, and there is just a little bit at the bottom. So I definitely don't want to add any more, and I don't need to, because it said what happens to the egg and the water as you add the salt. My egg is now floating. Okay. The other thing that we didn't mention is our water was displaced from 150 where we started, and it went up to 200. And that is because we added the weight of the egg. Now there is a math equation for that to calculate the weight of the, not the weight, the mass. Mass and weight are different. We can cover that right now. So mass is the amount of matter in that subject that can be taken anywhere, even on a different planet. Weight is based on Earth's gravity. It's the amount of weight pulled down by gravity. So they are different. However, they are just slightly different. So if you don't have grams, then you can use things like pounds and such. But remember that when you take your weight on a scale, you are taking your weight, not your mass. All right, so we need to write that our egg you write whatever happened in yours, and if yours didn't start floating, add more salt. Okay. Make sure that you're measuring the amount of salt you added. So I added 1 tablespoon salt. I always think tablespoon is TBSP, but it's actually TBS of salt. And my egg started to float. Not all of my salt dissolved. Okay. How much salt do you need to add in order to make the egg float? It was 1 tablespoon. Why does adding salt to the water make the egg float? Now, I also want to clarify that on this lab report, there are the questions right here. And so when I answer with 1 tablespoon, it makes sense. However, if I'm writing a lab report and I am answering how much salt do you need to add in order to make the egg float without having the question there, you need to have a complete sentence. And a complete sentence would be, I needed 1 tablespoon of salt in order to make my egg float. So different scenarios if you're at different levels. And right now, this is written for us and we're allowed to write on it. So 1 tablespoon works. Okay, next question. Why does adding salt to the water make the egg float? Why does it make it float? Do you know why? Hopefully you know why. Because the egg will sink because the egg is more blank than the water. The answer is the egg is more dense than the water. So, why does adding salt to the water make the egg float? Well, we changed the density of the water by adding the density of salt. So we made it where the water, the salt water, is now more dense than the egg. More dense water means item inside will float. Now, when the egg right here is more dense than the water, the egg will sink. Okay, so why does adding salt to the water make the egg float? The salt water is more dense than, and this than is than, THAN, because we are comparing. Comparing is AN. Okay, salt water is more dense than the egg. Okay, flip it over. If you didn't correct your answer to that second question there, make sure you fix it if it was not quite what we were looking for. And if you had it right, congratulations. All right, next, try to float an egg using some other items added to the glass of water. Be sure to make some good observations. Can you make an egg float in sugar water? Why or why not? Okay. What do you think? Can we make an egg float with sugar water? Now, off the top of my head, I don't know the density of sugar or the density of salt, but because they have weight and they have mass, I do know that they do have density. So there should be at least some point at which we can make the egg float with sugar. Now, can we get there? Or is sugar's density just not enough to match the egg's density? Okay, that's 1 tablespoon. I'm going to stir away. Again, we're dissolving, which means that this is still a physical change. We can boil this water and we can get sugar back out and we can get water back out. Sorry. All right, it looks like most of my sugar is dissolved. You can see my egg is just barely off the bottom. So my hypothesis is so far holding true. Now, let's try 2 tablespoons, and I'm getting sugar everywhere. 2 tablespoons. I almost used a pencil to stir my beaker. Okay. My egg is now floating. It does not seem to be floating as much as my salt with 2 tablespoons. So I am just going to measure that. 5. So this one is at 5.5 centimeters. And that is the egg's top, not the water. Okay. And in my salt, the egg top is at almost 6 centimeters. But what also did I not take into account? Are these eggs the same length? This one is 6 centimeters. This one is also 6 centimeters. I did a really good job at picking these eggs. Okay. So this one is just a little bit floating more than the sugar. And it took twice the amount of sugar than it took for salt. Okay. Can you make an egg float in sugar water? Why or why not? Yes. First, we should write above that our prediction. I said yes. I think that the amount of mass from the sugar will make the density of the water more than the egg. So I wrote above, yes, I believe the density of sugar added to the water will be more than the egg's density. So then my answer to can you make an egg float in sugar water is yes, you can. Why? The exact reason I said before is the density of the sugar water is more than the density of the egg. The egg's density. I need to clarify that. Okay. Can you make an egg float in oil and water? Why or why not? Okay. So we already have 2 beakers here that are floating with eggs. And if I was to add oil or soap to these, then I'm mixing oil or soap with sugar or salt. So I need to start with some fresh water and dispose of the water that I have in here and probably rinse my eggs off. So I'm going to do that and we will be right back. For you, it will be a second. For me, it will be a little longer. Okay. I'm still using the same amount or the same eggs. Sorry, my computer cord is not letting me push the computer back. Technology issues. Okay. Stay. Okay. So there was nothing changed with our egg. That was physical changes only. So our egg is still a raw egg, not affected, and nothing has changed with it. Okay, so it doesn't matter. We can use the same eggs, but we cannot pour our water in with the egg inside of it. So I'm gonna roll my egg out. Okay. Also, I'm going to put these back in the same order that I had them before. All right, fill them halfway with room temperature water. This jar is very confusing to me because 200 milliliters is right here and 100 milliliters is right here. So because of the glass length, it doesn't seem like my glass is half full, but based on my measurement, it is half full. So just a little observation that's driving me nuts. All right, can I make an egg float in oil and water? Take your prediction or your hypothesis. I think that, well, let's go with what I know. I know that oil, when put on water, floats because oil's density is less dense than water's density. So water is more dense than oil, which means oil floats on water. So if our egg is currently sunk to the bottom, then I don't believe floating oil is going to make egg float. But let's try. Okay, so egg 1, put him back in. Our water will displace. My egg should sink to the bottom. And now I am going to use my tablespoon. I should also write my prediction. Predict. No. Because oil floats. And I never know. I could be mistaken. I could not know. That's what science is for. But I am not wrong, okay? I am making an observation. I'm making a prediction. That does not mean I'm wrong if it doesn't go the way I had predicted, okay? It just means that I didn't get those results, and that's okay. The people that live in my house with me, my husband and my sister, they like to tighten lids very tight, and I am not as strong as them. So, okay, there we go. 1 tablespoon of oil has done nothing to the egg. The oil is floating. 2 tablespoons of oil, done nothing to the egg. The oil is floating. 3 tablespoons of oil, done nothing to the egg. The oil is still floating. And I am going to call it good because I now have 50 milliliters of oil in my beaker that is floating without the egg. So I am going to say that the density of water and the density of the egg are both higher than the density of oil. So no, I cannot. Too far. Okay, that was 1. No, the density of both the egg and the water are higher than the density of oil. So it's not possible for me to make this egg float with oil, but it's cool to try. All right, can I make an egg float in soap and water? Why or why not? I don't know the answer to this, but what I have learned is I don't think I have enough dish soap. So I'm gonna grab one that I have more of, so that way if I need multiple tablespoons, I'm not mixing dish soap, because different dish soaps could have different densities. And I don't want to mess with that. I want to keep everything the same and be consistent and that. So let me go get more soap. Okay, I now have enough soap. I don't know. On this one, I really don't know. I have never done an egg floating in soap and water. I do know that soap dissolves in water, but I don't know the density of my soap. I do know it has mass, but I don't know if that mass will make it where the egg is less dense than the soapy water. So I'm gonna take a guess. That's what this is. We're guessing, and it's hard. It's really hard. I want to say well, I really don't know what I want to say, because I kind of want to say yes, because what if it does float? But what if it doesn't? I mean, it is pretty thick. I know it's composed of multiple different ingredients, and those ingredients each have their own density that is mixed within this soap. So I think yes. I'm gonna go with yes. Okay, prediction. Yes. Soapy water will have lower density than the egg. All right, let's find out. I still have some sugar on my tablespoon, so I'm just going to dispose of that. Don't want that to interfere with our current experiment. Okay. Oh, you know what? I realized I didn't take note of how many tablespoons we did in the sugar water. It was 2 tablespoons for the sugar water. 2 tablespoons of sugar. And the oil, I did 3 tablespoons of oil. Okay, and now we're going to find out how many tablespoons of soap to see if we can get this egg to float. First, I have to put it in the beaker. Okay, it sunk. I feel like I'm wasting precious soap here. This is not wasting it. This is science. Okay, so soap sinks in water. Now we're dissolving it. The coloring of it is changing my color of the water, but my egg is still touching the bottom. Let's try another tablespoon. Pour it in. Stir it up. I'm definitely not eating this egg. Oh, oh. It has lifted. Now, it's not completely above the surface, so I am going to add another tablespoon. That would be my 3rd tablespoon. Just realized I should definitely try and make sure I count better. But lucky for me, I can just go back in the video and make sure that I am correct with how many I just did. Okay. One more. Quite certain this is 3. Because the first one did nothing. The second one made it go up. And now the third one, we should be floating. And you can also, I don't know if you can actually see a whole lot. So let me try and put some white background behind it. You can see that my water is now green. And it's not water anymore, it's soapy water, which is still a physical change. All right. It's now floating. I really think that I could get it to float a little bit more. So I'm going to go for my 4th tablespoon. If you don't want to go and you're going to take it's floating as it's floating because it's not touching the bottom, go for it. I just want to see how many it takes to get it the same amount off the ground as it did with salt and sugar. got a little higher, but I don't want to use any more soap. So I'm going to go with 3. It took 3 because 3 was the amount that it took to really get it off the ground. But 2, it was just barely lifted off the ground, so 2 could have counted 2. But I'm going to go with 3. 3 made it where it was actually floating. So it did match my prediction. Yes, soapy water can make an egg float because it has a higher density than the egg. 3 tablespoons of soap. Okay, in which mixture did the egg float the best, the worst, and why? I'm definitely thinking, so remember I used a ruler to measure mine, and the salt was higher than the sugar, and I know that just by looking at it that this soapy water is lower than the sugar. So I'm just going to do a 1, 2, 3 here, and 1 is the best, 3 is the worst. Actually, we should have 4 as the worst because we had 4 trials, and I think not floating is definitely the worst. Okay, so salt was the best. Second was sugar. Third was soap. And fourth was oil, which did nothing. Okay, why? Well, the oil floated itself, so it couldn't get the egg off the ground. The oil floated, so had no chance at getting egg to float. Okay. The salt had the highest centimeters of egg surface above water when floating. And the sugar still had more egg surface than the soap, but less than the water. Okay, we finished that page. Next page. Write an operational definition for each word. So we want to write our own definition of density, mass, buoyancy, molecules, and mixture. Now, I also want you to look up the exact definitions so you can compare your definition with the exact definition. I want you to try and write your definition first. Otherwise, your definition may be persuaded by dictionary's definition. And I always feel like I can't make the same words as the dictionary and it makes sense. So start with your thinking first. So density. Density is, well, I know there's an equation for it. Okay, so The formula for density is mass over volume. And we have volume as the amount of space can be taken up in this glass. And our mass is the amount of grams in the egg and the amount of grams in the water. But it's mainly just the egg. The amount of grams in the water is irrelevant here because we have water is a liquid, and liquid is measured by volume because liquid takes up space. So we measure it by volume. So it's mass of the egg, which egg 1 was 59 grams divided by the volume. And that volume before we added things was about 200. Or actually, we should take the volume before we put the egg in. So that was 150 on the 250 milliliters and 100 on the 200 milliliters. And if we put that into the calculator, that would give us our actual density amount. But we don't have to do that. So density, how would I define it? It is the amount of space. This is hard. The amount of space that a thing is, or the amount of space at which something can float or sink based on what has more density. And so therefore, if something is heavier, typically it has more density. But if something is lighter, typically it has less density. And if something is less dense than another thing, then that thing will float in water. And that thing's density also has to be less dense than the density of water, because pretty much everything has its own density. Okay, mass. Mass is the amount of matter within a thing. It is measured by grams. Buoyancy, that is the floating ability. That's how I describe it. Can it float? Does it float? And can we make it float? Molecules. Molecules is more than one element, and they are structured together. And it also could be molecules of one element, but there's two of them. So like oxygen is two oxygens connected together. That is a molecule. Okay. A mixture. A mixture is two things that are physically combined together, which produces a physical change, so we can still separate them. Okay, those are my definitions. Write your own definitions. Look up the exact definitions. Oh, look, we don't have to look them up. They're on the back. All right, density, a measure of how much mass is contained in a given unit. Volume, density equals mass over volume. Mass refers to the amount of matter that makes up an object. Buoyancy, the ability to float in a liquid or air. Molecules refers to two or more atoms which have chemically combined to form a single species, or just one is what it means. And a mixture when two or more substances are mixed together but not combined chemically. So there was no chemical change. Okay, there's also a little scientific explanation here. Adding salt to the water squishes more molecules into the water. This makes the water more dense. When there was no salt in the water, the egg was more dense than the water and it sank. Adding salt to the water makes the water more dense than the egg, which makes the egg float. If you weigh a cup of salt water and a cup of fresh water, sorry, the salt water will weigh more than the fresh water, even though it is taking up the same amount of space in a cup. This is because the salt water is more dense than the fresh water. And then there is a link there if you want to check it out. And that is all. We have finished our lab. All right. I am just gonna dispose of these eggs because I really don't want to eat this egg, the soapy egg. And I really don't want to eat that egg either because we were playing with it. So I'm just gonna dispose of them down the sink. Okay, and clean up your mess and see you next time. Remember to take attendance or participation and comment either on the Google Classroom of this assignment, the Google Classroom stream, or Mrs. Shear's Secondary Science, and put the emoji for the subject that you are participating in each week. All right, thank you. I hope you had fun with this one. I know this one's one of my favorites, and I've never done the oil and soap before, so that was fun for me. All right, till next time.